Now here, introduction to DSCS2. This is the lab number 7. We skip lab number 4, 5, and 6. We will do that after we finish this 7, 8, 9. This lab, this software. And objectives of these labs are to get familiar with DSCS2 software, to design a full adder as an example, to check the functionality of the design using simulation with built-in simulator, to match the output from the simulator with the truth table of the expression, to convert the schematic into the new symbol. That's it. Number 6, to generate Verilog file and layout design automatic from microwin. Okay, this is the lab. This is the part we will do after we do the 4, 5, and 6 lab. Okay, so we will get back to this one again. But at first, from 1 to 5, we will do that. Introduction. DSCS is a software. Okay, you can read by yourself. Today we will be designing full adders. Right? Full adder. What is a full adder actually? Full adder is an adder that can add 3 bits, right? 3 bits, A, B, and carry in. Why? What is half adder and what is full adder? Okay, let me give you a hint. Okay, if we add 1 and 1, what will be the result? If we add 1 and 1, what will be the result? The result will be 2, right? 2 in decimal, but in binary it will be 1 0.
1 0. Yeah.
Okay. Here 0 is the sum. This is the sum. What is 1? This is called carry, right? Carry. Okay. This is called carry out. That means output carry. Got my point? So here, this term, that means the first term, is our A. The second term is our B. So do you have anything in your hand at the beginning? No. What do I mean by that? Let me explain. No. If we add this multi-bit number, that means this is our A, this is our B. Upper one is our A. 111 means 7. And 101 means 5, right? Understood? In decimal actually. So if we add 5 and 7, what is your result? 12. 12, right? This is your result. But if you add this in binary, how will be your addition? See this one, 1 and 1. If we add, the result will be what? 1 0, right? That means 2.
1 0.
So 0 will be here. 1 that is in your hand, right?
Will be
1 that is in your hand. Okay. This one, where it will go? It will go the next stage, right? This one will go to the next stage. Okay. Now if you add 1 1 0, what will be your result? Again 2, right? Again your result will be 2. 2 means 1 0 again. So here it is your 0. And you will have another 1 in your hand, right? Got my point?
Sir.
Okay. Now this one, where this one will go? Sorry. Next stage, right? Next place. Got my point? So here, if you add 1 1 and 1, what is your result? 3, right? In decimal. Got my point? Everyone? Hello?
Yes, sir.
Okay. So 3 means 1 1. So this is 1 and this is 1. So from where? Okay, this is the one, this is the sum. And what is this? This was in your hand, right? But since we do not have anything in our places, so we will just put it in front of our result. Got my point? So 1100, that is equal to 12. So our result is correct. Got my point, everyone? So here, what I want you to see, that is, when we add two number, your result will be 2 bits. That means one will be sum, one will be carry. Okay, that carry will go to the next place. Now here we add, at the beginning, we add 2 bits, right? 2 inputs only. So that means we do not have anything in our hand from before, because this is the first bit. That's why we do not have anything from the previous stage. This is the start, right? So here we have to add two bits only. So we need half adder. We need what? Half adder. Half adder has 2 input and 2 output. What are the outputs? This 0 and 1, right? This 1 will be the carry, the 0 will be the sum. So 2 inputs, 2 outputs. That is the half adder. Now look at the next stage. For the next stage, your how many bits do you have? How many bits do you have? 3, right?
Yeah, 3.
You have 3 bits. But how many result do you have?
2 bits.
Still 2. So this is full adder. When your input is 3 and your output is 2, that is called full adder. When your input is 2 and your output is still 2, that is called half adder. Got my point?
Yes,
So
sir.
today we will be designing this half adder. No, not half adder. We'll be designing the full adder. So let's go to the lab sheet. Okay, the A, B, and C in. This is your inputs. A, B, C. This is your input. That means you have three inputs, and C out and sum. These are your outputs. So you have 2 outputs. So 3 inputs, 2 outputs. Got my point? Okay, let's draw a line so that you can understand easily. So these left side's numbers are our input, the right sides are our output. So now look at this. Here, look at this. A, B, C in, C out, and sum. So 0, 0, 0. If we add 0 plus 0 plus 0, so result will be 0, 0, right? If we add 0 plus 0 plus 1, result will be 1. What do you have in your hand? Nothing. That's why 0. If you add 0 plus 1 plus 0, result will be 1. So sum is 1. What is your carry? Nothing. 0 plus 1 plus 1, 2. 2 means 1, 0. So 1 will be carry, the sum will be 0. Understand? Hello? Understand?
Yes, sir.
Yes, sir. We understand.
Yes, sir.
1 plus 0 plus 0, result will be 0, 1. 1 plus 0 plus 1, result will be 1, 0. 1 plus 1 plus 0, result will be 1, 0. 1 plus 1 plus 1, result is 3. 3 means 1, 1. So this is your carry and sum. Now you have 3 inputs and 2 outputs, right? This is your output
Yes,
number 1. This is your output number 2. So you will have 2 expressions. 2 expressions for your circuit. One for carry out, one for sum. So let's go for the carry out. Okay, let's delete this part. Not delete. Let's hide this part.
Half adder, full adder.
Yeah. Let's hide this part and go for the one only, the 0 line. Okay. Let's draw a line. The 0 line is not needed. Not needed. Because they are producing zeros. So 0 we are not interested in. We are interested in only ones, right? Only the 1 numbers. Okay, only 1 we are interested in. Okay, everyone? Got my point? Now,
Okay, sir.
now look at this. Here, for this one, what is your state? A is 0. That means A bar. Here, A bar. B is 1. So B, directly B, no bar. C is 1. So C, no bar. Okay? So A bar, B, C. Got my point?
Yes, sir. Yes,
For
sir.
next one, A, B bar, C. Because B is 0, right? That's why B bar. Next one is
Yeah.
this one. Next one will be what? A, B,
A,
C in bar. Let me C bar actually. And the next one will be what? A, B, C. Okay? Understand?
Yes, understand, sir.
Okay. Now we will simplify this equation. How to simplify this? Here, look for pattern. Look for pattern where you can simplify. Okay, here I can simplify this one. I can take common C in and C in, right? I can take common. I will take common C in. What you are left with? You are left with A bar B and A B bar, right? So first one is done.
Yes.
Okay. Now look for the pattern A B. These AB and AB are common. So take AB common. So what you are left with? You are left with C in bar
C in bar and
and
C in.
C in.
C
Now
in.
C in bar and C in, they will produce 1. Why? A bar plus A is equal to 1, right? We know it. We know it, right? So if it is 1,
Yes, sir.
so this will be vanished. Only AB will remain. Okay? Only AB remains. Okay. Here, look at this. A bar B and A B bar is what?
XOR.
XOR, right? You know it. This is XOR.
Yeah.
A XOR B
Yes, sir.
plus AB. So here, how many gates you need? You need an XOR, you need an AND, you need another AND, you need an OR. XOR, and OR, right? XOR, and OR. So 4 gates you need here. Okay. For the next one, for the sum, let's do something similarly. I'm going to hide what? I'm going to hide the C out and we'll do what? We'll cut the zeros. This is 0. This is 0. This is also 0. And this is 0, right? We are cutting the 0 lines and we are sparing the ones, right? Can you see that? Okay.
A 1 1.
Okay. This one is what? A bar, B bar, C in. Next one, A bar, B, C in bar. Next one, A, B bar, C in bar, right? Next one is A, B, C. Can you see the equation? Hello?
Yes, sir. Yes, sir.
Now look for pattern again. Here we can take common. Okay, we can take C in bar common. These two we can take common. And remaining part will be A bar B and A B bar, right? So the first one is done. C in bar is common. So A bar B and A B bar. And look for pattern this one. Here you can see C in is common, right? So if I take C in common, what you are left with? A bar B bar and AB, right? Got my point? So here, if you dart more, you
C
will,
in bar.
yeah, you will see C in bar into A bar B, A B bar. Now this one is XOR, right?
Yes, sir.
This one is XOR. So I'm going to write C in bar A XOR B. Now this one is what? This one is XNOR. This one is what? XNOR. XNOR means what? XNOR means XOR bar, right? XOR bar. XOR is XOR bar, right? Understood? Hello?
Yeah, sir, we know.
Okay, you know it already. So from there, you can see here you have C in bar XOR plus C in XOR bar. So something like this: A bar B, A B bar, right? Or X bar Y plus X Y bar. Can you see that? Can you see the pattern? So here we
Yes, sir.
can
Yes,
call
sir.
this another XOR. So C in XOR A XOR B. So why I have put a bracket here? Because our A XOR B is already common. We have already found out here, right? So if we do that once, we can use the result twice.
Yes, sir.
Okay. So we need 5 gates for here. One for this AB, another one is for this XOR, another one is for these AND, another one is for this OR, another one is for this XOR. So 5 gates are needed. So I'm going to go to the software and show you how to do it. So this is our software DSCH. This is a pretty simple software, pretty small and simple software. Here you have a lot of files. These are the example files that I have done, my student has done, my teacher has done, and his teacher has done, and so on. So the point, these are the examples that we have done so far. So this is the DSCH, double click. Okay, the software has come, right? So this software, you already know it, right? I have done it before in front of you.
Yes, sir.
Remember?
Yes, sir.
So if I click F5, it will become
Yes, sir.
white. Okay, I need the black one. Here,
We know, sir.
I need A. This is our A. I need B. This is our B. I need C in. This is our C in. Double click. I'm going to write the name. A. Double click. I'm going to write the name B. C in, right? CI. Okay, CI is fine. CI. Now I need an XOR because our equation is A XOR B first. Let's do that first. What is the XOR? This is the XOR. Okay, I have brought an XOR here. Then we need an AND AB, and then C in A XOR B. So I'm going to bring one AND here. Okay, this one will be what? A XOR B into C in. So this will be going there. I need another AND gate for A and B here. I need an OR gate. Where is OR gate? Where is OR gate? Here is OR gate for C in A XOR B plus AB for this one. Then we need an output. Then we need another XOR for C in XOR A XOR B. For this one, we need another output for which one is carry? The upper one is carry because we are connecting like this. A, B, right? So what you can do for your easier understanding, you can double click this one and you can write the name. What is the name? A XOR, right? Okay, smaller one. XOR B. Can you see that? Okay. It is not showing because I didn't click the title, symbol title. Can you see that it is inside? So by doing that, you can understand, okay, this is A XOR B. So you will not forget. When the design is too complicated, you will not forget which one is which. Okay? Now this one, I will be doing AB. That is the multiplication of A and B. AB. So what I will do, I will bring it from A. I will bring it from B. Understand?
B.
Now this XOR will go there and will go there. So this one will come here. So what is this? This is A XOR B is coming and C in is also coming. So can I write C in bracket A XOR B like that? Double click title. Can I do that? C into A XOR B. Which part is this one? This part is this one, the first one. C in A XOR B, right? This is the first part. Can you see that?
C in, yes.
Okay. Now,
Yes, sir.
next what? This is also done. This is also done. Can I use the result of these two and add by using an OR gate?
Yes.
Okay, like this, right? Okay. Like CO. That something like that. It's a very big line, right? So I'm going to make it smaller. Okay. This is the result actually.
Okay.
The result will go
Yes,
where?
sir.
This result will go to our output. So can I write the name of the output called CO? Oh no. These input output namings are very important. The name of the inputs and outputs are very important. Why? Because we want to make it a symbol. We want to take the symbol and we want to use the symbol again and again and again. What is the symbol? This is a symbol. Okay, let me show. This is the design. Now, if you need adder, full adder multiple times, will you design this every time? Or you convert this thing to a symbol like this and use it every time? Which one? Which one is easier? If you need 10 adders, will you design that same adder again and again, or you just make a symbol previously, or if make a symbol before and use it again and again? Which one is easier?
The second one.
Yeah, second one, right? Okay, so
Yes,
what
sir.
you do, you design the adder and you make a
Yes.
symbol for later use, so that you can use this thing later, so that you can use it in your bigger design. So this is called symbol. Okay, we will make it a symbol. That's why, can you see the names of the pins A, B, C in, C out, and some? The name of the pin will depend on the input and output pins. That's my point. Whatever the name you are putting here, that will appear in your symbol. So if you do not change the names, default names, it will look like that. So that's why I told you, whenever you put your input and output, change the name. Okay, change the name how you like. Because if you do not change it, your output to name will remain there. This will not become sum. No, not happen. Got my point? Now this one here, one will be what? This one will be C. XR, no, small. XR bracket A XR B bracket. Title will be there. Well, this is the title. Now your result will be this one. And this one will come from where? This one will come from A XOR B. Can you see that A XOR B is coming and C in is coming? And the result will be sum, right? Just S. Sum is fine. So let's check the result, whether it is working or not. Wait, I run the simulation. Every what is that? Every line is blue because all of them are 0, right? And nothing is gray. If something is gray, you'll understand. What is the gray? Okay, if I delete this line, you will see something is gray. No, nothing is gray. Maybe this point is gray. Okay. So if something is gray, that means there is a problem. So you have to do it again, or you have to check the connections. Okay, now let's do that. Yeah, 0, 0, 0 means result is 0, 0. 0, 0, 1 means result is 0, 1. 0, 1, 0 is result is 0, 1. 0, 1, 1 is result will be 1, 1, right? No, 1, 0, sorry. 1, 0, 1 is 1, 0. 1, 1, 0 is 1, 0. And 1, 1, 1 means what? Result?
1, 0.
No, 1, 1, 1.
2 0.
2, 0? What is your 1, 1, 1?
2 1, sir.
That means 2, 1, right? That means 1, 1. Result will be 1, 1. See? 1, 1, 1, result is 1, 1. Understand? Okay?
Yes.
Okay. Now I want to save it. I have to save it. Go to file, save as. Where you will save it? In the same folder. In the same damn folder, you will save it, right? You will save it. I'm going to write a full adder D26, right? And I'm going to give my name T for tafsir. Do not give any space. Do not give any space and try to write the name as small as possible. As small as possible. This is important. Why this is important, I'll explain later. But this is important. Try to write the name as small as possible. Do not give any space. Okay? And look at the file type. What is the file type? This is called SCH. What? Oh, by the way, can you see the screen? Oh,
Yes.
The file type is called SCH. HCH. Do you know why? .sch. This is a schematic file. Schematic means design. The whole design is called schematic. This is a schematic file. That's why this is the file extension is SCH. .sch file, schematic file. Okay. Schematic file. Okay. I'm going to save it as a schematic file. Now I want to make a symbol. The symbol, how to make the symbol? After saving it, go to file, make schema to new symbol. Schematic to symbol. Schematic to symbol. It is here. Can you see the symbol is here? So I can make the symbol bigger or smaller. That's my wish. I want the smaller one better. I like the smaller one better. This one. But see, my A should be at the top. My B should be at the middle. My C should be at the bottom. My carry out should be at the top. Sum should be at the bottom. How can I do that? I can change the position here. L means left side. Right, R means right side. I can change the position 1, 2, 3 or 3, 2, 1. Or I can click increasing order, decreasing order, whatever. I can manually change it. Like 3 will be 2, 2 will be 3. I can do that. Here, our A is at the top, B is at the middle, C in as at the bottom, C out at the top, sum is at the bottom. That's fine. So here, in the same folder, it will be saved, and the schematic and the extension will be .sch. No, not sch. SYM symbol. Okay, done. Now I want to check it. Go to the insert user symbol. See, what is the file type? What is the file type? SYM. Can you see that?
Yes, sir.
This circuit is called schematic. That means SCH. And this is the symbol SYM symbol. I'm going to click, and this is, can you see that? Full adder D26 SYM is there. So if I open it, this is your symbol. Okay. Now again, if I want to check it, let's check it. One input, two input, three input. This is the output. This is the output. So if I click one, any one, the bottom one will be on, right? If I click two, the top one will be on. Three, one will be on, right? So our symbol is working. Since our symbol is working, I can go and take a nap, or I can have my lunch. I can close it. I can come back again. I can open the software and I can use my symbol anytime I want. Go to the insert, user symbol. Use this symbol whenever you need. Whenever you need, it is ready. Got my point? When it will be ready, when it will be needed. It will be needed for bigger design like this one, like this one. Okay. Here you need four adders. Like this one. Here you need 4 adders. Can you see that? 1, 2, 3, 4. That time you do not have to design the whole circuit. You just bring the symbol and work with it. Understand my point?
Yes, sir.
Hafiz, you got it? Hafiz?
Yes, sir. Please, sir.
Yeah? Hello?
Yes, sir. We got.
Okay. So can you practice it
Understand.
right now?
We can try, sir.
So you can try. You have the software, go to the software and make the circuit. Which circuit? This circuit.
Full adder.
Okay. The step-by-step process is given in your lab sheet. Follow the lab sheet and what? And try to make it, right? I'm going to stop the recording.